So the last major piece of code that we need to complete our linked list is our iterator. And we're going to see two different interfaces, iterator and iterable. So if I have just a simple array of integers, I just call my variable name ARR for array. It's not a very good variable name, you shouldn't do that. But it works. Oops. Here's an array of integers. And one of the things that we often want to do with data structures like like arrays, like linked lists, other kinds of data structures, is to write a block of code something like this. For int I equals 0, I is less than variable name array dot length, I plus plus. Now we're going to do something. For example, let's just print it out. Okay, now we print it out. But maybe we want to do something more complex. This is, oh, sorry, that's not what I wanted. We want to print the value in the array. Okay. This is really common code. We do this all the time. And so the developers of Java said, you know, this is so common that we use this. We'll come up with a special interface, and the interface is called iterable. And if you tell us that your data structure is iterable, that it implements the iterable interface, we'll allow you to use a shortcut instead of writing that code. And the shortcut looks like this. For int, I'm going to call it x, and then you put a colon, and then you put the variable name, array. Or for int x, a colon, list, for your linked lists. And now you can do whatever you want. So for example, system out print when x. Okay. So these two blocks of code do the same thing. They're equivalent code, and to do this, you need to implement the iterable interface. If you implement the iterable interface, Java will allow you to do that. That's cool, we should do that with our data structures. That's what we want to do. The iterable interface only has one method that we have to complete. That method has a signature public iterator e iterator. Okay. And what that says is that we're going to have a class that implements the iterator e interface, and we're going to give you an instance of that class. If we give you an instance of that class, you can use this shorthand code. So in your iterator code in the linked list, all you need to do is return a new instance of iterator helper. Okay. We're just going to return a new instance of iterator helper. And where does this iterator helper come from? You guys have to write it. So let's take a look at the iterator helper class. You guys all have this piece of code? Okay, so in our linked list, you're going to have your linked list definition, public class, linked list, E implements, list I, E. Okay. You're going to have your linked list, you're going to have your add first, add last, remove last, peek first, peek last, size, is empty, is full, make empty. I think that's it. Methods. And then we're going to have another inner class. Remember our node class that creates these nodes? It's an inner class, right? It's secret. Only our linked list has access to that inner class. And the same is true with our iterator helper. So we're going to have an inner class, iterator helper. And this is the class that our iterator method is returning an instance of. And it's going to implement iterator E. Okay? And this is where things are going to get a bit gnarly. So the Iterator E interface has two methods that you have to implement. Public Boolean has next and public E next. Okay. And let me explain what they are. If I have a list, let's say I have a list of numbers, 1, 2, 3, 4. If my pointer is at number 2, hasNext will return true because I have something to return, the number 2. When it calls next, I'm going to return the number 2 and I'm going to move the pointer forward. Okay? So when I get called next, I remember that I need to return number 2 and I move the pointer forward to number 3. When I'm at number 3, hasNext returns true because I've got a 3 to return. When I am asked for next, then I remember the number 3 that I'm going to return. I move my pointer forward to number 4. When I'm at number 4, hasNext returns true. When I get called for next, I remember number 4. I move my pointer forward and my pointer points to null. When my pointer is null, hasNext returns false. Okay? So my hasNext method, all I need to do is just check and see whether my temporary pointer is pointing to null. Yep. Okay. Hey, Koo, there's some problems with the video. Apparently it's not working. No word. Yeah.
So the next returns the previous value, I guess, after you...
It returns where you are, right? And then you remember that, and you move the pointer forward. Okay. Have we got video, Koo? Hopefully you guys are following along. I'm recording it, and I'll post these videos online if we if we lose the video. Okay, I'll check. All right, so far so good, okay? And we'll come back to the actual implementation of has next and next in a second. But this is where things get really gnarly. Here he comes. Have we got video?
Yeah, so I have them press the refresh.
Okay.
I just did it and it came back on.
Okay, cool. Can you guys post on Slido to press refresh? Thanks. Because obviously if I say press refresh, they won't know. All right, so how many of you are absolutely sure that you're using Java 1.8? How many of you are absolutely sure that you're not using Java 1.8, that you're using Java 1.7 or Java 1.6 or Java 1.5? How many of you are not sure whether you're using Java 1.8? Right. So you guys are about to find out if you're using Java 1.8. And the reason is that between Java 1.7 and Java 1.8, they made a bunch of changes to Java. And one of the changes that they made, actually two of the changes that they made, affect the Iterator interface and are going to affect the implementation of this. Okay? So the first change that they made is that in Java 1.8, interfaces can provide default implementations of methods. The only methods that you can't provide default implementations of are hashcode equals and toString. And why is that? Because those default implementations are in object, right? So the first change is that implementations in interfaces can provide default methods. So there's a method in the Iterator interface that has the signature public void remove. And the default implementation in Java 1.8 is throw new unsupported operation exception. That should be on one word, but I'm running out of space there. Okay. So if you're using Java 1.8, you don't need to worry about the remove method. If when you write your iterator helper and Eclipse says, you know what, you've screwed up and it's not compiling because you've got unimplemented methods and the unimplemented method is a remove, all you need to do is write exactly this method, public void remove, throw new unsupported operation exception, and put it into your iterator helper inner class. Okay? That's the first change. If you're using Java 1.8, you don't need to do that. You can ignore this method. We don't use this method. It's stupid to have a remove method in an iterator, and that's why they've provided this default. The other change that they made is that in the iterator class, iterator interface, there is a public void for each remaining. And again, you don't need to worry about that. In fact, nobody needs to worry about that because there's a default method which doesn't do anything. And if you're not using Java 1.8, you don't have that. And if you are using Java 1.8, it has a default method. Okay. So in our iterator helper, in case it says you've got unimplemented methods, it means you're not using Java 1.8, you're using an earlier version of Java. So in our class, in our inner class, we're going to have a temporary pointer that we're going to use to point to our linked list. So let's just call that something different. We've already used current, we've already used previous, we've already used temp. Let's call that index. Just so that it's clearly a different variable. When we're looking through our code, if we saw current again, we'd say, well, is that the same current as previous? The same current as before? But by using a different variable name, it helps us keep clear index is just in this inner class. And now we're going to have a constructor, public iterator helper.
So we still have that issue after when we refresh. So do you still want your students to see it live right now? If so, I could start another presentation. They're just going to have to click on a new link that's on the Blackboard.
Yeah.
It might take me a few seconds to set that up before I'll stop it and
Okay.
change it over. And I'll come back in and let you know when that works.
Okay, cool. Thank you, Ku. Technology, isn't it great? So we're going to have a constructor, public iterator helper. When we initiate, we set index to point to head. Okay. Now here's our hasNext method, public boolean hasNext. So all we want to know is index null. If index is null, we don't have anything to return. Either the list is empty, and we've set index to point to an empty list, or we're at the end of the list, and we've already iterated through everything, and so we're done. So all we need to do is return. Now, if index is null, we don't have anything to return, so we want to return index not equal to null. Index not equal to null. If index is not null, then hasNext should be true because we've got something that we want you to have. And then we have our next method, public eNext. The first thing we want to take care of is, do we have an empty list? How do we know we have an empty list? hasNext won't return true. So if not hasNext, here we can maybe throw a new no such element exception. Okay. Let me put that on one line so it's clearer. Throw new no such element exception. Okay. So if we don't have anything to return, we want to tell people. If we do have something to return, let's make a variable called value that we'll remember. It's a type E, and that's going to be index.data. Index equals index.next. Return val. So this is the code for Iterator Helper in a class. If you're using Java 1.8, that should suffice. Okay. It goes inside your linked list class, and it allows you to use that syntax that I already showed you. So you can say, for example, for int I in list. When you're testing your code, you should be able to then just use system out println to print the numbers that you've added to your linked list.